All right, today we're talking about a breakthrough that sounds like it's straight out of science fiction. We're going to look at how AI is being taught to see like a doctor, and how that one skill could literally mean the difference between life and death in an emergency.
So, picture this. You're in a chaotic emergency, maybe a car crash or even a battlefield. A medic's got a tool that could save a life, but there's a catch. They have to know how to read what it's showing them, and fast. So what if a machine, an AI, could step in right then and there and give them that expert vision? That's the huge question we're digging into.
Okay, so to get to the answer, we've got to start with this amazing medical tool. A tool that, for all its power, has one pretty critical, life-threatening catch. That tool is called point-of-care ultrasound, or POCUS for short. Now just think of it like a pocket-sized window that lets you see inside the body. In a serious trauma situation, this thing is an absolute game changer. It lets medics check for dangerous internal bleeding right on the spot. No hospital required. Super fast, non-invasive, it's incredible.
And this is where we hit the big problem. The promise of POCUS, it's huge. I mean, it's fast, you can take it anywhere, it saves lives, but, and this is a big but, actually reading an ultrasound, it's really, really hard. It takes a ton of training, and the reality is there just aren't enough experts to go around, especially not in the places where you need them most, like on a battlefield or in a rural clinic. You know, the researchers who did this work, Ruiz and their team, they nailed it when they said it. The true benefit of this amazing tool is basically locked away. It's stuck behind this massive skill gap. I mean, you can have the coolest tech in the world, but if nobody knows how to use it right, what's the point?
So the obvious next step was, hey, let's get AI on this. And the first idea seemed super simple, super logical. But let's just say it didn't exactly go to plan. The first thought was, okay, let's just treat this like any other image problem we've solved with AI. You know the drill. You get thousands of single ultrasound pictures, you label them bleeding or no bleeding, and then you just train the AI to see the pattern. Easy peasy, right?
Well, not so much. When they actually tested this thing in a real-time situation, the results were pretty bad. For an abdominal scan, it was only right about 70% of the time. And the pelvic scan? 59%. You might as well just flip a coin.
So why did it fail so badly? Well, the AI was looking at the problem all wrong. It was only seeing a single static snapshot, and one ultrasound picture can be super ambiguous. The AI just couldn't take what it learned from still photos and apply it to the messy, moving, real-world chaos of a live scan.
But this failure led to a moment of pure genius. The researchers had this huge realization. They weren't teaching the AI to think like a doctor, they were just teaching it to look at a single photo. What it really needed to do was watch the whole movie.
So yeah, the old way was all about that one snapshot. The AI looks at one frame by itself and misses all the good stuff. It misses the context you get from the probe moving around, from seeing things at slightly different angles. All that crucial info was just gone.
The new way, though, totally different. Instead of just one frame, they started grouping a bunch of frames together, one after the other. Basically, they created a little movie clip. And when they fed that whole sequence to the AI, boom! It could suddenly see the movement, the changing angles. It could see the context, just like a human expert would. It finally had the missing piece of the puzzle.
And what's so brilliant about this is that it's exactly how the real experts do it. A doctor doesn't just glance at one single picture and make a call. No way. They scan the whole area, they move the probe around, they're taking in information from all these different angles over a few seconds before they make a diagnosis. The AI was finally doing the same thing.
So the big question is, did it work? Did teaching the AI to think more like a doctor actually make a difference? Well, let me tell you, the results weren't just a small improvement. They were a total game changer.
Okay, so first, let's remember where we started. The old models were hovering around 65% accuracy, which, let's be honest, is nowhere near good enough when someone's life is on the line.
In the new movie clip model, it blasted that number up to over 90%. That's not just a little better. That's the leap from being a glorified coin toss to being a legit, reliable tool you can trust.
And check out the most dramatic turnaround. Remember that pelvic scan that was failing with 59% accuracy? The new method hit 94%. That is an incredible jump. It went from basically useless to amazingly effective, all because they changed how it looked at the data.
And this wasn't just a one-off success. The performance was amazing across the board. We're talking 94–95% accuracy for both pelvic and abdominal scans. And maybe even more important, the precision was also sky high. That basically means when it says there's a problem, you can really trust it. These are the kinds of numbers that make people in the field actually want to use this thing.
Now, numbers this good aren't just for a research paper. They have real, immediate impact out in the field. In those life or death situations, a jump in accuracy like this means smarter decisions, faster treatment, and yeah, it means more lives saved.
So what's the bottom line here? It means medics can make faster, better decisions about who needs help first. It takes a huge amount of pressure off overworked doctors and nurses. It means we can save more lives in tough places, like on the battlefield or in a small rural hospital. And, maybe most importantly, it gives less trained people the power to perform like experts.
And let's be super clear about something. This isn't about replacing doctors or experts, not at all. It's about giving them a super-powered assistant. It's a tool that fills a dangerous gap when an expert just isn't there, making sure every medic has a little bit of that expert wisdom right in their pocket.
So, in the end, this whole incredible breakthrough came from one simple, powerful idea. Stop showing the AI a single photograph and let it watch the whole movie. And that kind of leaves us with a big final question, doesn't it? What other huge problems could we solve in medicine or anywhere else if we just started teaching our AIs to see the bigger picture?